Each of the letters L, O, N, E, S, T, A, and R are placed on a slip of paper. A slip of paper is pulled out and a letter is recorded in the order in which the slip was drawn. This is done 4 times. If the slip is not replaced after the letter is recorded, find the probability that the word note, N-O-T-E, is formed. Well, the first thing I need to decide is this, does order matter or not? Well, yeah, because N-O-T-E, we want it in that order. Order matters. Therefore, we are going to be using a permutation. Because the slip is not replaced, we know that that is a valid permutation, because permutations, we can only have the items taken only once. And so because it's not replaced, it can't be drawn again. So this truly is a permutation. So I am trying to find the permutation of, we have 8 letters and we're drawing them 4 times. So we have 8, choose 4. So I have 8, use my probability key to find the permutation button, choose 4, and that turns out to be 1,680. Okay, but that's not the probability. The question said find the probability that the word note is going to form. The permutation of 8, choose 4 is the number of possibilities of ways you could pull out any random 4 numbers. So if I'm trying to find the probability of getting the word N-O-T-E, well, there's only one way to get N-O-T-E in that order. So we have 1 out of 1,680, and that is the probability. Now let's change the problem up a little bit. If the slip is replaced after the letter is recorded, find the probability that the word note is formed. Again, order matters still, but this is not a permutation. And the reason this is not a permutation is because the slip is replaced. So you might accidentally pull the same slip twice, right? So in that case, it's not a permutation, and we will have to use, instead of the permutation formula, the multiplication principle. We have 4 spots, and we need to fill them. So on our first pull, we have a possibility of 8 different letters we could pull from the word Lone Star. Now, because the slip of paper is put back in, I still have the same 8 choices for the next time. And then when we put the slip of paper back in, it's 8 choices again and 8 choices again. And we have 8 to the 4, which is going to be 4,096 different ways that we could pull out the 4 letters, given that the slip is replaced after the letter is recorded. So now, what is the probability of getting N-O-T-E? Well, we still only have one choice of getting the letters N-O-T-E in that order, but this time we have 4,096 possible ways because we keep putting the slip of paper back in, so it's less likely that these letters are going to come out the exact way we want them to. Now let's change it up one more time. If the slip of paper is replaced after the letter is recorded, find the probability that no words have repeated letters. So you keep putting back the slip of paper back in, and you're hoping not to pick that again. Okay, so we're looking for the probability of different letters this time, which is a possibility because you keep putting the slip of paper back in. Again, this is not a permutation because it's replaced. So what we're going to try to figure out is how many total ways could we pull. Well, this is the same as 8 to the 4, which we found in part B for the denominator. That's the total number of ways you could pull. But my question is, I want the probability that no letter has been repeated. The word has no repeated letters. So we're going to use the multiplication principle for my numerator. I have 8 different choices for my very first pull. Now, even though I put back the slip of paper, I really only have 7 choices left because I can't repeat whatever the first one was. And even though I put the piece of paper back on after the second pull, I'm gonna only have 6 choices left after that because I can't have either the first or the second letter that I've already recorded. And then the last one I only have 5 choices left because I can't have the same letters that were recorded on the first 3. So when I get out my calculator, I'm going to have in the numerator 8 times 7 times 6 times 5 divided by, in the denominator, I have 8 to the 4th. And then let's see if I can't put that back in a fraction. And that comes out to be 105 over 256. So this is the probability that we will get different letters when we pull the 4 slips of paper out. Next, suppose that there are 5 people in a room. Find the probability that at least 2 people have the same birthday. Now, the same birthday refers to the same month and the same day, not necessarily the same year, and we're going to ignore leap years. So we're trying to find the probability that at least 2 people have the same birthday. Now, instead of thinking of it at least 2, it's more like at least 1 birthday repeats. Because if you only have 1 person in the room, they can't have the same birthday. So the first one doesn't really matter. It's the second one that has a repeat birthday of someone else in the room. Now, here's a hint. The probability of an event happening at least once, which is what we were talking about, at least 1 birthday repeats. That's going to be the probability of the event happening at least once equals 1 minus the probability that it doesn't happen. So we're going to look at finding the probability the event does not happen. So, and then we can subtract that from 1. So we're going to focus on that first. So to find the probability that the event does not happen, we need those 5 people in the room to have different birthdays. So we have 365 different choices for the first person. The second person can't have the same as the first person's birthday, so that's 364 times 363 times 362 times 361. So that is the total number of ways that the birthdays can't be the same out of the 5 people. Note that this is a permutation of 365, choose 5. So that's just a faster way of writing it, but we kind of thought about it more as a multiplication principle problem. So these are the ways that it's not gonna happen. Now, how many total ways could we have the 5 people have the birthdays? Well, in that case, we have just 365 times 365 5 times, which is just really 365 to the 5th. So the probability that they're not the same birthday is going to be a permutation of 365 choose 5 divided by 365 to the 5th. So I'm going to get my calculator out for that one. So 365 probability button choose 5 divided by 365 to the 5th. And that is going to get us 0.9728. So therefore, I am now looking for the probability of at least 1 repeated birthday is going to be 1 minus the probability of the 365 choose 5 with a permutation and then 365 to the 5th. I'm going to store that value in for x and then 1 minus x. That's going to get me 0.0271. So for the 5 people, the probability that at least 1 birthday is repeated is 0.0271. So if I start increasing the number of people, so for example, if I want 10 people, my formula for at least 1 repeated birthday is basically going to stay the same, except instead of a 5, I have 10. So I'm having a permutation of 365, choose 10, divided by 365 to the 10th. And I can repeat that all the way for even more and more people that enter the room. then I'm going to do it all the way up to 23. And 23 is an interesting case because when you walk in a room and you find out someone in that room has the same birthday as you, often people are like, oh my gosh, that's such a coincidence, right? I can't believe that. But it turns out that it's actually much more likely than you think. If you have a large group of people, that at least one person in the room has a repeated birthday. So we're going to go ahead and type this in our calculators. So I'm going to take 1 minus, in the numerator I have 365 permutation 10, close that parentheses, divided by 365 to the 10. And that gets me 0.1169. Next I'm going to just repeat that, but instead of 10, I'm going to type in 15. So I just went up and re-edited the values, and that gets me 0.2529. Again, changing it for 20, I'm just going to go up and then come in here and change the 15s to 20s so I don't have to type that all over again. And that's 0.4114. And then notice that we're getting close to a half here. So I'm going to do it one more time, and this time I'm going to use 23. And this comes out to be 0.5072. Maybe we could round that up to 3. So it only takes 23 people in the room to have a 1/2 chance of getting at least one repeated birthday. So 23 people, that's like a classroom full of people. So if you look around the class, the next class that you're in, so if there's 23 people or more, there's a pretty good chance that at least one person is going to share a birthday with someone else in the room.